Spread spectrum in mobile computing. It is a technique used for wireless communication in telecommunication and radio communication. In this technique, the frequency of transmitted signals such as electrical signal, electromagnetic signal or acoustic signal is deliberately varied and generates a much greater bandwidth than the signal would have if its frequency weren't varied. In broad, spectrum spread spectrum is a technique in which the transmitted signals of specific frequencies are varied slightly to obtain greater bandwidth as compared to initial bandwidth. Spread spectrum technology is widely used in radio signal transmission because it can easily reduce noise and other signal issues. Let's see an example to understand the concept of spread spectrum in wireless communication. We know that a conventional wireless signal frequency is usually specified in megahertz or gigahertz. It doesn't change with time. Sometimes it is exceptionally changed in the form of a small rapid fluctuation that generally occur due to modulation. Suppose you want to listen to FM stereo at frequency 104.8 megahertz on your radio, and then once you set the frequency the signal stays at 104.8 megahertz. It does not go up to 105.1 megahertz or down to 101.1 megahertz. You see that your set digits on the radio's frequency dial stay at the same at all the times until you change it. The frequency of a conventional wireless signal is capped as constant to keep the bandwidth within certain limit. And the signal can be easily located by someone who wants to retrieve the information. In this conventional wireless communication model, you may face two problems. The first one, a signal whose frequency is constant is subject to catastrophic interference. And this interference occurs when another signal is transmitted on or near the frequency of a specified signal. Second one, a constant frequency signal can easily be intercepted, so it is not suitable for the application in which information must be kept confidential between the source and the receiver. The spread spectrum model is used to overcome with this conventional communication model where the transmitted signal frequency is deliberately varied over the comparatively large segment of electromagnetic radiation spectrum. This variation is done according to a specific but complicated mathematical function. If the receiver wants to intercept the signal, it must be tuned to frequency that vary precisely according to this function. Why do we choose a spectrum? Spread spectrum signals are distributed over a wide range of frequency and then collected and received back to the receiver. On the other hand, wideband signals are noise-like and challenging to detect. Initially, the spread spectrum was adopted in military application because of its resistance to jamming and difficulty intercepting. Now, this is also used in commercial wireless communication. It is most preferred because of its useful bandwidth utilization ability. Bluetooth technology in mobile computing. It is high speed and low powered wireless technology designed to connect phones or other portable equipment for communication or file transmission. This is based on mobile computing technology. It is also known as IEEE 802.15 standard or specification, which uses low power radio communication to link phones, computers and other network devices over a short distance without using any type of connecting wires. Bluetooth is an open wireless technology which is used to send or receive data to connected devices present across a certain distance using a band of 2.4 to 2.485 gigahertz. In Bluetooth technology, wireless signals transmit data and files over a short distance, typically up to 30 feet or 10 meters. Bluetooth technology was developed by a group of 5 companies known as Special Interest Group, formed in 1998, and those 5 companies were Ericsson, Intel, Nokia, IBM, and Toshiba. The range of Bluetooth technology for data exchange was up to 10 meters in older versions of devices, but the latest version of Bluetooth technology, that is called Bluetooth 5.0, can exchange data in range of about 40 to 400 meters. The average speed of data transmission in Bluetooth technology was around 1 Mbps in a very first version. Later on, it went up to 24 Mbps in the latest version of this technology 5.0. When we talk about the history of Bluetooth, this is just amazing story behind this technology. Bluetooth wireless technology was named after a Danish king named Harald Blatant. His last name means Bluetooth in English. The name Bluetooth was awarded to this technology because Danish king named Harald Blatant was united the Denmark and Norway. Same as Bluetooth wireless technology is used to unite two disparate devices for communication or data transmission. In the architecture of Bluetooth technology, the network of Bluetooth consists of personal area network. The architecture of Bluetooth is also called Piconet because it is made of multiple networks. It contains minimum of 2 to a maximum of 8 Bluetooth peer devices. It usually contains a single master up to 7 slaves devices. Piconet provides the technology which facilitate data transmission based on its nodes, master nodes or slave nodes, where master node is responsible for sending the data while the slave nodes are used to receive the data. In Bluetooth technology, data transmission occurs through ultra high frequency and short wavelength radio wave. The Piconet uses the concept of multiplexing and spread spectrum, which is a combination of code division multiple access CDMA and frequency hopping spread spectrum FHSS technique. Let's talk about the working of Bluetooth. As we state that there is one master and up to 7 slave nodes may exist in Bluetooth connection. The master is the device that initiates communication with other devices. The master device handles the communication link and the traffic between itself and the slave devices associated with it. The slave devices have to respond to master device and synchronize their transmit and receive timing with the master device specified timing. When we talk about the communication between master node and slave node, it means there are exchange of messages, exchange of data packets. There are core specification of Bluetooth technology which consist of 5 layers. Radio, it is used to specify the requirements for radio transmission such as frequency, modulation and power characteristics for a Bluetooth transceiver. Second layer is called baseband layer. It is used to define physical and logical channel, voice or data link type, various packet formats, transmit and receive, timing, channel control and the mechanism for frequency hopping and device addressing. It also specifies point-to-point or point-to-multipoint links. The length range of a packet can vary from 68 bits to a maximum of 3071 bits. The third layer is called Link Manager Protocol (LMP). The Link Manager Protocol is used to define the procedures for link setup and ongoing link management. Next layer is called Logical Link Control and Adaptation Protocol. It is used for adapting upper layer protocols to the baseband layer. Next layer is Service Discovery Protocol, which facilitates the Bluetooth devices to query other Bluetooth devices for device information, provide services and the characteristics of those services. Wireless Application Protocol in mobile computing. It is a programming model or an application environment and set of communication protocol based on the concept of the World Wide Web, and its hierarchical design is very much similar to TCP/IP protocol stack design. There are a few prominent features of wireless application protocol in mobile computing. It is a de facto standard or a protocol designed for micro browser and that enables the mobile devices to interact, exchange and transmit information over the internet. Wireless application protocol is based upon the concept of World Wide Web, and the backend functioning also remains similar to World Wide Web that uses the markup language, wireless markup language, to access the wireless application protocol, while World Wide Web uses HTML as a markup language. WML is defined as XML 1.0 application. Wireless application protocol was opted as a de facto standard because of its ability to create web application for mobile devices. When we talk about the working of web, it consists of three levels known as client, gateway and origin server. When the user opens the browser in his or her mobile devices, selects the website that she or he wants to view, the mobile device sends the URL encoded request via the network to a web gateway using web protocol. The request he or she sends via mobile to web gateway is called as encoding request. The sent encoding request is translated through web gateway and then forwarded in the form of conventional HTTP URL request over the internet. When the request reaches a specified web server, the server processes the request just as it would handle any other request and sends the response back to the mobile device through web gateway. Now, the WML file's final response can be seen in the browser of the mobile users. When we talk about web protocol stack, which specify the different communication and data transmission layer in web model, application layer, which consists of wireless application environment, mobile device specification, and contain development programming language. Session layer, the session layer consists of wireless session protocol, which is responsible for fast connection, suspension and reconnection. Transaction layer, it consists of wireless transaction protocol and runs on the top of user datagram protocol, and this layer is part of TCP IP and offers transaction support. Security layer, it contains wireless transaction layer security and responsible for data integrity, privacy and authentication during data transmission. Transport layer, this layer consists of wireless datagram protocol which provides the consistent data format to higher layer of the web protocol stack. There are a list of advantages of using web. It is very fast-paced technology. It is an open source technology completely free of cost. It can be implemented on multiple platforms. It is independent of network standards. It provides higher controlling options. It is implemented near to internet model. By using web, you can send or receive real-time data. Nowadays, most modern mobile phones and devices support web. There are few advantages as well. The connection speed in web is slow and there is limited availability also. In some areas, the ability to connect to internet is very sparse, and in some other areas, internet access is entirely unavailable. It is less secured. Web provides a small user interface. Mobile IP. It is an Internet Engineering Task Force reference to 2002 de facto standard communication protocol, which is created by extending Internet Protocol IP. Mobile IP allows mobile devices users to move from one network to another while maintaining the same permanent IP address. The concept and role of mobile IP are very important in the field of mobile computing technology. Mobile IP makes the communication flawless and ensures that communication will occur without the user's session or connections being dropped. Mobile IP is based on the IP, so it is scalable for the internet. Any media that supports IP can also support mobile IP. In IP network, when a device is within its home network, routing is based on the static IP addresses. The device within the network is connected through normal IP routing by the IP address assigned on the network. It is the same as how a postal letter is delivered to a fixed address on the envelope. The problem occurs when a device goes away from its home network and is no longer reachable using normal IP routing. In this condition, the active sessions or devices are terminated. The objective of mobile IP was introduced to resolve that problem. Mobile IP facilitates users to keep the same IP address while going to a different network or a different wireless adapter without using communication, and if they don't want to disrupt their existing session. The mobility function of mobile IP preferred on the network layer rather than the physical layer. Let's talk about the architecture of mobile IP, which consists of many components. Mobile node, home agent, foreign agent, home network, foreign network, corresponding nodes, and care of address. Mobile node is a device or a user or a router that can frequently change their network position without changing its original IP address. Example of mobile nodes are cell phone, personal digital assistant, PDA, laptop, etc., whose software enables network roaming capabilities. The home agent is a router on the home network which served as the anchor point for communication with the mobile node. Foreign agent is a router that provides several services such as tunneling datagrams whenever a mobile node visits foreign network. It is responsible for delivering packets from the home agent to the mobile node. Home network is the base station network to which the mobile node originally belongs to. Foreign network, any network other than the home network, is called foreign network. Corresponding nodes, those are partner nodes which are used for communication. Care of address is used to define the mobile node's current position or user. Let's discuss the working of mobile IP. It is described in three phases. Agent discovery. In this phase, the mobile nodes discover their foreign or home agents. The home agent and foreign agent advertise their services on the network using the ICMP router discovery protocol. Next phase is registration. The registration phase is responsible for informing the current location of the home agent and foreign agent for the correct forwarding of packets. Next phase is tunneling. This phase is used to establish a virtual connection as a pipe for moving the data packets between a tunnel entry and a tunnel endpoint. If we talk about the application of mobile IP, it is used in many applications where the sudden changes in network connectivity and IP address can cause problem. It was designed to support seamless and continuous internet connectivity. It is used in many wired and wireless environment where users have to carry their mobile devices across multiple LAN subnets. Although mobile IP is not required within cellular systems such as 3G, it is often used in 3G system to provide seamless IP mobility between different packets data serving node domains. Mobile agents in mobile computing. Mobile agents are composition of computer software and data that can autonomously move from one computer to another computer and continue its execution on the destination computer. In other words, you can say that an mobile agent is an autonomous program that is capable of moving from host to a host in a network and interact with the resources and the other agents. In this process, the chance of data loss is scarce because the state of a running program is saved and then transported to the new host. Mobile agents allows the program to continue execution from where it left off before migration. The most significant advantage of mobile agents is the possibility of moving complex processing function to the location where you have enormous amount of data and that have to be processed. Mobile agents are also called transportable agents, which are classified into two types. Mobile agents with predefined path, they have a static migration path, and mobile agents with undefined path such as roamer, they have dynamic migration path. There are features of mobile agents such as intelligence, autonomous, mobility, communicative. Mobile agents are capable of learning and searching for knowledge about their domain. That's why they are called intelligent agents, because they possess a degree of domain knowledge They can also transport their state from one environment to another without disturbing the previous holding data and be capable of performing appropriately in the new environment. The mobile agents are called autonomous because they are not only motivated by the outside actions initiated by the users or system, but also they have internal events which decided their performance and behavior. The mobile agents can also take an autonomous decision while selecting a node. Mobile agents contain some degree of mobility. The agent is not limited to its home node only. They can migrate from one node to another and can carry out tasks along with them. This feature distributes the processing and balancing of the load. Another benefit of this capability is that when the user goes offline, the agents will still keep functioning. Mobile agents can communicate effectively with other agents, users, and system. The mobile agents use a communication language for inter-agent communication. There are advantage of mobile agents. They are autonomous, self-driven in a nature. They are maintenance friendly, easily maintainable, fault tolerant. They reduce the compilation time. They provide less delay in the network. They provide fewer loads on the network. They facilitate parallel processing. They provide dynamic adaptation. The disadvantage of mobile agents are the most significant disadvantage is the security. They are less secured. Let's talk about the application. Mobile agents are applied in a wide range of domains such as e-commerce, traffic control, network management, robotics, data intensive application. They are also used in grid computing, parallel computing, distributed computing, and mobile computing.